We have a system, 200-year-old system called platform framing, and we do it because we think it's efficient. It's an efficient use of wood for the structure, but everything else, we're doing a lot of work to make them waterproof, to make them high performance. And we know so much more now than we did 200 years ago. And so our approach would be really a complete holistic approach. We can essentially design the house to anticipate where the sun is every single minute of every day throughout the entire year, and then use that to either heat the building in the winter or keep the building cool in the summer. We design a well-insulated building with high-performing windows, well-insulated walls, and then we use the geothermal to be the starting point for all heating and cooling throughout the year. And then we use solar panels on the roof to run everything else.
Welcome to Mindful Businesses, Our Sustainable Home, and I'm your host, Vidya Iyer. In our podcast, we bring to you organizations that are mindful in their practices and processes. A mindful business adopts and employs sustainable social, economic, and environmental practices. In our series, Our Sustainable Home, we talk about resources, options, and innovations in the construction industry. Mindful Businesses has, since July of 2019, met several innovators, creators, and thought leaders. But we realized that the process and the path to build a sustainable home was at best confusing and ever-evolving. We reached out to one of our earlier guests to pick his brain to help us navigate through this process. Eric Corey Freed, a lead fellow, is the Director of Sustainability at Canon Design, an architecture firm that creates living-centered design. Welcome, Eric. He joins us from Portland, Oregon.
Hi, everybody. How are you?
There were 1.6 million total newly privately owned housing starts in 2021. In our earlier conversations, we talked that sustainability does not mean just tacking on a couple of green features to your home, but we should look into air quality, use of directional light, how natural light can play a role in your moods and your well-being, and a multitude of things. These conversations with you actually pushed me to investigate ways to make our home here in Buffalo, New York, more sustainable. And that was not easy at all. How does one even begin? I'm asking you for help. Help me, Eric. How do I even start processing all that information out there?
There certainly is a lot of information. And I think the best way to start is to just start. Really start thinking about what your priorities are with the house. So whether you're renovating an existing house or whether you're building a new house, as you are, what are your priorities? And think of it that way. Sustainability is not cinnamon. You can't just sprinkle it on top. You have to kind of think of it holistically. So if we're designing a new house, to me, it really begins with the site. What's the property you're building it on? What is its relationship to the sun, to the wind, to the street, to nature, to its surroundings? And then with that, you start to lay out the form. And then as you kind of evolve the design, then a lot of these priorities start to take prominence.
I'm actually always partial to a west-facing lot because I'm a morning person. Most of the time, my kitchen is on the east side. So when I get up and have my cup of coffee and the sun streaming through the windows, and if I want to spend some time in the evening on the deck in the backyard, I have the cool evening in the backyard. So I personally, in our project, I sought out a lot which was west-facing, and we were able to find one.
The other thing that I always reminded people, the early part of my career was doing residential, and I would remind clients that just because the street runs in a certain direction doesn't mean that the house has to run parallel to the street. We can orient the house any way we want. And once you kind of have them let go of that idea where the house can orient to the sun instead of the street, then suddenly you create opportunities, right? If we're turning the house to face the sun and to create experiences like you're talking about, right? I want to rise in the morning with the eastern sun in the breakfast room. I want to sit on the deck in the evening and enjoy the sunset. I want to dine with the sunsets. That's another common one. Once we start to kind of free ourselves from having to orient to the street, and you can turn the house any way you want, their minds kind of exploded. And then it creates these great little areas within the site itself. So if the house is turned, even in Buffalo, New York, which has the worst winters ever, you could still create these beautiful opportunities for landscaping and outdoor rooms and outdoor spaces based on how you're turning this house in this form on this plot of land.
So once I've gone about this whole process of trying to pick a lot, and what you've assured me is that it's not so crucial that to have this ideal facing lot, but it's the house. You can build the house anyway. You can change the rooms and the backyard in a way that most suits your lifestyle.
But it sounds like you had already considered these things from the start, which was great. It was always a drag to me when clients had a lot that they had already purchased without asking their architects. And it was a north-facing lot that got no sunlight at any point during the day. They bought it because they looked at it on paper or they liked the location, but they didn't think about sun at all. And I guess they didn't spend enough time on the lot to begin with. That's hard to fix. But any other lot, it really is opportunities. One of my favorites is a lot of clients assume that all the lots have to be flat too. And in truth, you get a lot that has some sort of slope to it that starts to add character. Now, obviously, that might also increase construction cost depending on what you're doing, but also it's an opportunity for the house to really engage with the site in a much more interesting way.
And truth be told, our previous conversation in which you talked about directional light made me read a little bit more, get more informed before we went ahead and purchased this lot. What are the other components that a person should look into?
The very first things that anybody should do if they're thinking about planning a home is what we architects call the program. And most people might think of a program like a computer program, but when architects talk about a program, it's really just a list of all the spaces in the one in the house. And it doesn't have to be the list of spaces you necessarily grew up with, right? I was certainly this way. When I grew up, we had this formal dining room, and we never used it. It just sat there empty all the time. We had a family room that we used all the time, and then we had this living room that we only used once a week, maybe when guests would come over. But it sat with this perfect clean furniture, and the kids weren't allowed in there. You're not limited to any of that stuff. If you decide that you don't want a formal dining room, you don't have to have one. Now, obviously, that might affect resale value if you're worried about that kind of thing. But really, you can invent whatever types of spaces you want. Some of this really boils down to your personality. I had an old college professor, and he used to say that there are two types of people when it comes to designing houses. There are treehouse people, and there are cave people, meaning there are people that like these kind of treehouse-like spaces. They're bright, they're airy, they're off the ground. They usually have a view or an expanse, and that's one type of personality. And then there are cave people that like these kind of dark, small, cozy nook spaces. And then some people are both, right? They like to be treehouse people for their living room and cave people for their bedroom. But if you start to think about what types of functions, what types of spaces do I want to have, that's a great start. And then that starts to lead into the design of things like the kitchen. Do I want a big social kitchen where, everybody comes over and they stand around and talk while I cook? Or do I want kind of more of a utilitarian kitchen where the guests can be comfortable in the living room and we'll be preparing the meal behind closed doors? Everybody's slightly different. But if you start to get in touch with your personality that way, it starts to open up opportunities of how we design it. And then sustainability is woven throughout that. If I know I'm designing a big social kitchen, well, then I'm probably going to design it with a big skylight that's going to let a lot of light in, so I don't need lights on during the day. I'm probably going to design it so it has a view to the backyard. I'm probably going to design it with some sort of pass-through so the seasons allow, we can kind of eat outside, right outside of the kitchen, and I can hand dishes and platters through a window or something. Suddenly, the house starts to really design itself.
You talked about sustainability, but what are the few things, if you are trying to build a sustainable home, would you want to look into?
There's several buckets. Some people get very interested in energy. They kind of assume that a green building is one that's very energy efficient, and that's certainly true, but that's only part of the story. We can design an energy efficient building in any climate anywhere in the world. In your case, you're in Buffalo, New York. Buffalo has lovely summers and, as I said, rough winters.
You almost seem to enjoy it when you say that.
I love Buffalo. I've been there in the winter and I've been there in the summer, and summer's better. You want to design a nice, cozy place. And the way we can do that is, let's use Buffalo as an example. Why wouldn't we design a house that essentially, once the sun rises in the morning, it starts to warm up the house in the winter. And then throughout the day, the house receives that warmth through the winter, and the house is designed to do that. And then when the sun is setting in the west in the evening, it's designed to reduce the glare so we can enjoy the sunrise without squinting or having tears in our eyes. That's a very specific approach to orientation. And then the walls themselves are designed to either insulate and keep your heating in, or they're designed to absorb heat, like a big stone wall or a concrete wall that has a lot of what we call thermal mass that'll store up the heat from the sun all day and then release it at night when it's really cold. Then in the summer, we almost do the opposite, right? We control the heat gain in the summer. So in the morning, we design the orientation so that way it blocks the sun coming up in the morning so you can see it and gives you light, but doesn't heat up your house. And so your house doesn't get stuffy. And then it's controlling the southern sun throughout the day with overhangs, and then creating a space on the west side so you can enjoy it in the evening. These techniques have been around for thousands of years, if you really think about it, and formally in architecture for at least 60 years. And so we can essentially design the house to anticipate where the sun is every single minute of every day throughout the entire year, and then use that to either heat the building in the winter or keep the building cool in the summer. When it's done right, it's beautiful.
We still need a source of energy. So what we are planning to do with our home is to use geothermal.
Oh, nice.
And we need a pump for the geothermal to work. Folks who don't know what geothermal is should listen to our earlier episode with Dandelion Energy. So geothermal requires a pump, and the pump needs energy, of course, to operate. So if you put solar panels, or if you use that energy for the pump, you are basically very quickly self-sufficient. You're net zero.
Yeah, very easy to do. A geothermal heat pump system is very energy efficient to begin with. And think about how it works, right? Most of us want the house around 68 degrees all year long. With geothermal, what you're doing is you're sticking roots into the ground, you're running a closed loop water system, and you're bringing up water that's around 55 degrees. And so you're starting from 55 degrees, and all you have to do is get it from 55 to 68. And we use that either for heating or for cooling, but we're starting at a number that's much closer to what we're comfortable with. Now contrast that with what we normally do. In the winter, we suck in outside air, which is maybe 30 degrees or sometimes colder. And we're starting now at 30 degrees and trying to heat that up to 68. It takes a lot more energy, a lot more effort to do that. That's why a geothermal system is so efficient. But it does require electricity to run. And so our approach would be really a complete holistic approach. We design a well-insulated building with high-performing windows, well-insulated walls, well-sealed using all the best practices that we normally do. And then we use the geothermal to be the starting point for all heating and cooling throughout the year. And this could be either radiant heating or cooling that's in the floor, very cozy, or it could just be a normal forced air system that blows air on you, but the geothermal is the source of the warmth. And then we use solar panels on the roof to run everything else after we have a well-designed, very highly efficient, high-performance building.
So basically you're saying start with reducing your energy consumption by building a well-insulated home, the windows, the direction, the skylights, the lights. You don't need that many lights on if you have natural light during the day. And taking that footprint, you say, hey, how much energy would I need? And then with geothermal, which is a super efficient way, you use that and the solar panels to overall reduce your energy consumption.
Yes, exactly. Two things to keep in mind. If you remember nothing else from this conversation, there's two nice tidbits that I want to remind you of. Number one is that solar panels are the last thing we do, not the first thing. We do the solar panels after we've reduced the base load of the building.
And actually, was an interesting thing that you brought up, because most people, they say, hey, we're going to put solar panels and we will be off the grid. No, you will not be. That's a really good point.
And then the second one, that's my favorite, is that insulation is like chocolate. The more you have, the better. So a well-insulated wall is a beautiful thing and pays for itself. Insulation's cheap, so it pays for itself in a matter of months. So whatever the added cost is of having slightly thicker walls with slightly better or more insulation in them is well worth it, especially in a climate like New York.
This brings us to the next point about insulation. I've been researching all kinds of insulations, all kinds of wall constructions. The traditional wood frame home is built with your 2x4s. Would you like to explain how a traditional wood frame home is built?
The way we build houses today has been relatively unchanged for 200 years, believe it or not. We've been building the same way for 200 years, which is really weird because there's probably nothing else in your life that still is using a 200-year-old technology. Certainly not your phone or your car or your computer or even how your clothes are made. But in architecture, we're still using this 200-year-old technology called platform framing. And the idea is simple. You take little sticks of wood, 2x4s, 2x6s, and then we do them 16 inches on center. And then those sticks, they might fall down. So what we have to do is give them some rigidity. So we put plywood on the outside, and that stiffens them up. And then that wood has no insulative value, so we have to add insulation. So between the studs in those 16 inches, we roll insulation, usually like that pink fiberglass stuff, but there's plenty of other options. And then that fiberglass is itchy, and so we have to cover that. So we cover the inside with usually some sort of drywall. And then the drywall is ugly. So what we do is we tape it and hide all the seams and smooth it out. And then we have to cover it with something, usually paint or wallpaper. And then the edges of it are ugly. So then we have to hide that with crown molding or base, right? Floor base. And then the floors themselves are also covered in plywood. So we have to cover that with something, carpet or tile. So we have a system, 200-year-old system called platform framing, and we do it because we think it's efficient. But if you really get into it, it's not that efficient. It's an efficient use of wood for the structure, but everything else, we're doing a lot of work to make these little sticks habitable, to make them waterproof, to make them high performance. And we know so much more now than we did 200 years ago. But yet we still build out of little sticks of wood at 16 inches on center. It's ridiculous at times because we go to great lengths to do this only because we're so used to it and we're familiar with it. That's really the only advantage that it still has, is that it's ubiquitous.
So let's deconstruct this whole wall system. Say we still wanted to use the sticks. We have the labor who's used to that. You cannot change everything in one shot. What modification could we make in this stick model to make it more efficient? Because right now we put the fiberglass insulation between the studs. There's so much heat loss on either side.
You're asking a great question because that's the holistic approach of, okay, how do we make this idea much more modern and efficient? And so, okay, if we're going to do studs, and the studs are engineered for strength, and I get that, what if we did slightly larger studs? So instead of 2x4s, we do 2x6s. And then instead of putting them at 16 inches on center, we can put them on 24 inches on center. So what we've done is essentially we've taken out every fourth stud. The reason that we did 16 in the first place is because everything in construction is some module of 8 inches. Concrete block is 16 inches, bricks are 8 inches, plywood comes 48 inches. Everything's in some module of 8 inches anyway. So 16 became naturally. But 24 is also in a module of 8 inches. So instead of 16 on center, we'll do 24 on center. And now everything still lines up. And then we will be ruthless about sticking to that module. So we won't have waste. So we're not going to make a wall that's 24 feet and 3 inches. We'd either make it 24 feet or some other module of 24. And then we'll space the windows to be within those spacing cavities. So we're not going to have a 26-inch window. We'd either have a 24-inch window or a 48-inch window, so we can take advantage and reduce waste there. And then we're going to take the thicker walls and we're going to insulate them with really good insulation. So now what we've done is, just by being a little smarter, I've saved you 30% of the wood that you would normally use in the building. I've saved you more than half of the waste that you would normally generate building the building. The building looks the same. It's just a little smarter in terms of how we size the windows, how we size the doors, how we size the building. And just by doing those simple things, what's called optimum value engineering for the framing, I've saved you money and I've made a higher performing, better insulated building. That's the easy stuff. And that's a great place to start.
So what about the thermal loss on the outside where the plywood is and on the inside where the gypsum board is?
There's a phenomenon called thermal bridging. And you've all probably experienced thermal bridging if you've had an old house that had like aluminum windows or metal windows. And you touch that metal window in the winter and it's freezing. Or even worse, on the inside of the house, it starts to get condensation on it because the metal frame is so cold that when it hits the inside air, water droplets form on it. When I was growing up, we had metal windows, and I used to get icicles forming on the window because the cold would come through the window, it would hit the warm air inside, and there'd be so much condensation it would freeze. It was bizarre. That is called thermal bridging. Since we're building these studs and they're going through to the outside, there is a little bit of what's called thermal bridging. Not a lot, because wood is not that great of a conductor, but enough to worry about it. So there are things that we can do around that, around sealing, around putting the skin on the outside, and then using different techniques of how we essentially finish the skin of the outside of the building. And so we can improve the performance, reduce the thermal bridging, and we have the insulation on top of it. And so that's an easy way to do it. Or there are alternative structural systems beyond just little sticks of wood.
In the course of talking to different builders and people who have built sustainable home, we heard the construction terminology, staggered studs. Explain what are staggered studs. How would that construction be different than the sticks model? Would you recommend that, or is it just a waste of money?
So normally when we do the little sticks of wood, 2x4s at 16 inches on center, we just do them all in a row. Staggering the studs is where essentially you're building almost two walls where the studs are now spaced slightly apart. And so the stud that's holding the outside skin, your siding or whatever, is one stud. And then there's another stud next to it that's pushed inside, and that's holding the drywall. And by staggering the studs, I've broken that thermal bridge. So now the cold air isn't leaking through the stud and then coming through the other stud. There's two separate studs and there's an air gap between. So they are thermally broken is what it's called. The benefit of that is you get a thicker wall and I guess more space for insulation. The drawback is you're using now a lot more wood. I have a lot of builders that like that, especially in cold climates like northern New York. But my advice would be don't do the staggered stud because of the material costs, and instead use an alternative material like either SIPs or ICFs. And SIPs stand for structural insulated panel. ICF stands for insulated concrete form. And they're both very different. SIPs are basically wood sandwich panels, plywood on each side with foam in the middle. And ICFs look like giant Legos that are hollow. And you stack them up and they kind of stick together. And then you fill them with concrete. So one gives you a very well-insulated wood building. And ICFs give you a very well-insulated concrete building. Two very different buildings, but both kind of much more interesting systems if you're building a new house.
The drawback I've heard about the ICF and the SIPs is that you cannot make any changes. These are made in factories.
No.
And even the plumbing, your electricals, everything has to be predetermined before they actually make that for you. Is that true?
It's not true. First of all, the SIPs come with these cores already drilled through the center of them, these kind of holes. So you have a big rectangular sandwich panel, and then you have these vertical cylinders of nothing in the middle, and that's where we can run the plumbing and the electrical. Let's say, whoops, you forgot a pipe, or whoops, you forgot a conduit. You can, on the site, really cut into the SIP and then run whatever you need to run. It happens all the time, unfortunately, because we're sometimes forget things or sometimes add things. So it totally can be done. It gets a little more drastic if you forget a window. Whereas in wood framing, if you forget a window, literally just take a saw and just cut it out and stick a window in. If you forget a window in SIPs, we kind of do the same thing, but it's a little messier because now we're cutting a pre-made panel that has foam in it, but it can be done. I don't recommend it. But here's the other part. Generally, we've planned out all the electrical and plumbing and windows anyway. So on a SIP building, it's pretty easy. ICF, it's a little harder because you're pouring concrete. And so if you forget something with the concrete, yeah, it's a little more annoying. But again, for conduits, it's easy because we cut into the foam and recess it into the foam anyway. If we forget plumbing like a drain pipe, then that's a little more serious. And if we forget a window, that's even more serious because now we're jackhammering a concrete wall, and that's a lot of added cost and labor and time that we generally don't want to spend.
So in terms of cost, the first option that you gave us, putting studs 24 inches off center with instead of a 2x4, go with a 2x6. Do you get the same R values as the ICF and SIPs? Or do you have to compromise on that?
You can get the same R value. Really depends on the wall assembly and what type of insulation you're using. So let me caveat that. But generally, you're getting close. The SIP is generally going to give you a little more insulated value because it's thicker. It's also all in one. The ICF is going to give you great R value because the blocks are made of insulation, but it's also going to give you great strength because the inside is made of concrete. So you're kind of getting the best of both worlds. You're getting a well-insulated concrete building, but not everybody wants a concrete building or needs a concrete building. ICF's insulated concrete forms are great in Florida because you've got hurricanes. They build out a concrete block there anyway. You've got the insulation, which you need. You've got the concrete, which you need. It's a win-win-win. For Buffalo, I'd rather go with a wood frame type of structure like SIPs or studs. and it makes a lot of a lot of sense there from a climate perspective.
Yeah, I was just in Florida 2 weeks ago, and I was visiting my friend, and I looked around at all the new construction which is going around there, and they all have concrete structures. And concrete, if you talk about sustainability, concrete has some of the other negative things that cement brings along. Cement puts out 6 to 8% of the greenhouse gases that our world has today. It's a balance, right? So now we go with wood, which is sort of sustainable if you get wood, which is not from, I don't even know if you get 2x4s from sustainable forest.
You can actually, you can look for, there's a certification called Forest Stewardship Council, FSC, and you can buy FSC certified wood that you know has been sustainably harvested from well-managed forest. It's a great label to look for. There's also an alternative label called SFI, the Sustainable Forest Initiative, not as stringent, not as good as FSC in my mind, but it's yet another label. And, do your own research. You don't have to take my word for it. But there are ways to get studs that way. There's also reclaimed studs. As we demolish one house, if those studs are in there, they're easy to, believe it or not, they're easy to take out. And you remove the old nails and screws, and it's a perfectly good stud. And so depending on where you live, there might be opportunities to do that as well.
Actually, I was about to ask you about reclaimed studs because I've been talking to a mill up in close to Rochester, which has reclaimed floors, and they have FSC floors, like for wood floors. And the question is, which is better? Which is more sustainable?
Because studs are the structure of the building, you can't just use any wood that you find and use it to hold up the walls. They have to be graded. So typically, if you want to use reclaimed studs, you have to find studs that were previously studs and graded and then take them out and reuse them. Otherwise, the building inspector will not let you. When it comes to something like flooring or siding, a finished material, because that's not structural, you can get beautiful wood from reclaimed sources. And so in my 30 years, I've done reclaimed wood from old barns, from old train bridges, from reclaimed from old high school gymnasiums that have been reused as floor. And the benefits are you're usually getting a wood that you couldn't even get today, especially, the ones that we use from old barns. Maybe that wood was initially milled 150 years ago. Well, that's gorgeous old growth wood with a really beautiful tight grain in it. I couldn't get that if I tried today. So I'm taking this beautiful old wood that normally would get thrown away. I'm refinishing it and using it as a new floor or a new wall. And I'm getting a better looking floor, and it's not that expensive. So reclaimed flooring is, to me, such an easy no-brainer thing to do. Depending on where it's sourced from, usually it ends up getting remilled anyway. So they'll sand it, they'll take the old boards and they can add a tongue and groove to it. You're not just taking some old board off of a fence and putting it into your floor. It's really bringing out the old life of the wood. But also consider the alternative. A lot of people will buy this, what we call engineered floor, like Pergo or something similar. And what that is, basically sawdust that's been glued together, and then they put a thin veneer of wood on top. So it's not really a wood floor. It's really a sawdust floor, if you think about it. And the glue that they use to hold together the sawdust is 85% formaldehyde, which is what we embalm dead people in. So you're taking this pretty nasty stuff, you're putting this in your house, and when you install it, of course, it has to be cut. And as soon as they cut it, it starts off-gassing more of these chemicals, and it creates a very stinky floor. The only good part is that it's durable, this kind of glued together solid engineered thing. And that's how they sell it, that it's this super durable floor. But what you're getting is a bunch of kind of nasty chemicals in the process.
Actually, your explanation probably explains why when I went to visit a friend who had pergo floors, my feet would burn.
Oh, yeah.
I would get like some kind of a tingling sensation, and I had to always walk around with shoes. I like to walk around bare feet, but there was something in that home that was bothering my foot. My voice would get a little raspy, things like that. I never thought about the formaldehyde until you brought it up.
There are a lot of people that are very sensitive to it. I myself am very sensitive to it. It's described as an odorless gas, but I'm now so sensitive to it that if I walk in, my throat starts to close up and I immediately think, is there formaldehyde off-gassing in here? And we use formaldehyde as a binder in so many glues. The typical pink insulation is held together with formaldehyde. You can get formaldehyde-free versions of most things anyway, but you just have to ask for them. By default, you're going to end up getting the cheaper, more formaldehyde-laden stuff.
So now we have the basic construction, at least for me, I'm going to look for reclaimed studs, build it 24 inches off center, 2x6, and I would put plywood on the outside and wrap it. You know, when you drive in new subdivisions, you see the Tyvek wrap or the Lowe's wrap. But I have heard some negative reviews about those wraps, about condensation, how they trap condensation. Is that true?
Tyvek's a brand name, but there's lots of these building papers, and typically once we build the sticks and then we wrap it in plywood or particle board, we kind of waterproof it a little bit, and we use this building paper. And you've all seen Tyvek because it's what they also make FedEx envelopes out of, is Tyvek. It almost feels like paper, but it's plasticky and it's incredibly durable. That's also building paper, essentially. But in the wrong installation, you can end up creating a problem. So you can end up getting condensation forming between the Tyvek and the plywood or in the stud cavity. And then condensation in the wrong place could lead to mold. So we could have been unknowingly creating buildings that lended themselves to mold production. And mold, of course, is tied to health risks and damage and all that other stuff. There are a lot of alternatives to Tyvek, and one of them is, I'm not plugging this necessarily, I just am a fan of it. It's called Zip Wall, and it's designed as kind of a breathable system of waterproofing, and it's really done for contractors. And all my contractor friends love this Zip Wall. Constantly posting about it on Instagram, taking pictures of them with the Zip Wall. But it's really a smartly designed system of wrapping the building quickly with no joints and seams and a reduction of risk of mold or condensation.
Explain Zip Walls to us. So the technology part of it, from what I've read, it seems to say that you reduce labor costs because it's just one application.
Yes, definitely.
And there are these liquid nails which you put into, or liquid seams?
Yeah, they're seam. It's very clever because essentially the paper is designed with these strips, and that's where the zipping comes from. You put up these panels, they have these essentially tapes you peel off and you stick them on, and all the seams are done, and it goes boom, boom, boom. So it's basically the siding and the building paper and the seams all in one. So it certainly saves time and labor, which is time is money. But it also creates for a better insulated, better performing system. Remember, in buildings, our big enemy is water. We do so many things in buildings, whether they're homes or office buildings or schools or hospitals. We do so many things to keep water out. And so we're constantly fighting water intrusion. And the zip wall system is minimizing the number of joints between materials where water could intrude. It's even smart around the window and door openings because those are another potential source of drafts or water intrusion. And it's just a very quick, smart system.
So basically, I wouldn't have the plywood and the Tyvek. I would have this other system.
Yeah, it's moisture and air protection and sheathing all in one. And then the zip wall, by the way, is green instead of white, which is a great branding thing because as you drive by, you can see that it's different. But remember, then you can cover the house with whatever you want. Whether you're using Tyvek or zip system or something else, you can still put siding on it, whatever you want. The siding could be stucco. It could be normal wood siding. It could be vinyl siding if you want to do that, which I think looks cheap, but you could. Then there's things like hardy board. So you could finish it in any number of ways to make a very modern looking or very traditional looking or whatever type of thing you're trying to do. But we're really talking about what's going on underneath the siding. So the zip wall, the Tyvek, all of that occurs under the siding and normally is invisible after the house is done.
We've encompassed a lot of steps and I wanted to thank you. But when you talked about siding, I have other options, which I hope we can talk again and discuss those options and share with our listeners who either want to renovate a home to make it more sustainable or build a new home. Thank you so much, Eric, for your wisdom.
Oh, my pleasure. Thank you so much for having me. And obviously, it's a big topic. There's plenty to cover, but it's always fun to talk about these things.
You're listening to Mindful Businesses, Our Sustainable Home, a podcast series that helps you navigate the complex process of building and making your home sustainable. We would love to hear from you. Send a voice note with your questions or comments to info@mindfulbusinessespodcast.com. Subscribe, rate, and review us on Apple Podcast. If you learned a thing or two from this episode, share it with one friend. We recorded this podcast in Buffalo, New York, Theme music composed by Tatum Gale. Our marketing assistant is Roseanne Korean. Our advisors are Jim Stone and Anupama Pastricha. This is Vidya Iyer with Mindful Businesses.